The last half of this section is about planes, and a plane is specified by a point in the plane, so a point on it, and a vector normal to the plane. And when we write normal, I'm going to write perpendicular here, the symbol for perpendicular, just to save some writing. Okay, so let's consider a plane containing the point P, call it x1, y1, z1, and with normal, non-zero vector n equal to a, b, c. Okay. And if you want a picture, I'm going to say look at page 801 in your textbook. So the plane is the set of all points Q such that PQ is perpendicular to the normal vector. Well, what does it mean for two vectors to be perpendicular? That means that their dot product must be 0, and that's what we're going to use to write the equation of the plane. So PQ is the vector x minus x1, y minus y1, z minus z1, and n is the vector ABC, and that dot product must be 0. So let's just compute that dot product. I get A times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0. And this is the standard form of the equation of a plane. Now, of course, you could distribute and combine constant terms. So the general form of the equation of a plane looks like ax plus by plus cz plus some constant d equals 0. Okay, notice here in the general form, we still can pick off the normal vector. N is still composed of the coefficients of x, y, and z. So n is a, b, c. Is orthogonal to the plane. All right, so let's try an example. Let A be the point 215 and N be the vector -2, 3, 1, and let's say be normal to the plane containing A. Find the equation of the plane. Well, we just need to plug into the formula. It's still here at the top of the screen. So my A, B, C are the components of N, and my X1, Y1, Z1 are the components of my point A. So I just plug in. So I get -2 times X minus 2 plus 3 times Y minus 1 plus 1 times z minus 5, right? Equals 0. Don't forget the equals 0. If you don't have that, you don't have an equation. Okay, so equals 0. And that's it. Let's try something a little bit more complicated. So here I want you to find the equation of the plane containing the points P, 1, 3, 2, Q is the point 3, negative 1, 6, and R is the point 5, 2, 0. Well, what do I need to find the equation of a plane? I need a point in the plane, and I need a vector normal to the plane. Right now, I just have 3 points in the plane, but think about what we did last section. What did we talk about? We talked about the cross product of two vectors, and what did we say about the cross product of two vectors? It's normal to the two vectors. So the plane containing these 3 points is going to contain the vectors formed by these points. So in particular, PQ and PR are vectors in the plane. And so if I take their cross product, I'm going to get a vector that's normal to both PQ and PR. And in particular, it's going to be normal to my plane. So PQ crossed with PR will be normal to the plane. So let's call this N. All right, so at this point, you should be comfortable with finding these vectors. So PQ is going to be 2, negative 4, 4. And PR is 4, negative 1, negative 2. Now, for the sake of your attention span and time, I'm just going to tell you that if I cross PQ with PR, what I get is 12I plus 20J plus 14K. Now you should double check that, but I'm not going to show you the work here. And now I've got my normal vector, and I just need to pick a point. Let's use P as my point and N as my N. And so the equation of the plane is 12 times x minus 1 plus 20 times y minus 3 plus 14 times z minus 2 equals 0. Now, if you distribute and combine like terms, what you should end up with here is 6x plus 10y plus 7z minus 50 equals 0. So you can see not only have I combined like terms, I ended up with something where all the terms were even, so I divided through by 2. Okay, so this is the equation of my plane. And I just want to show you pictorially what's happening. So let's switch over to GeoGebra for a second. So I've already plotted my points, wow, P, Q, and R, and there, oh no, undo. There we go. Okay, let me get off of the arrows. All right, so here are my points P, Q, and R, and I can find PR and PQ. There we go. So there are my vectors. So my plane is the plane containing these two vectors, and so here's the equation of the plane, and it's there. Now you can see a little bit better. That blue is my plane, and you can see those two vectors lie in the plane, as do the 3 points. Okay. All right, given two planes, whoops, let's not use the highlighter. How might they behave together in space? Well, they're either parallel, in which case they never intersect, or they intersect in a line. Okay. We can find the angle between two planes with normal vectors n1 and n2 respectively, just by using the angle between the two vectors. Okay. As, let's say, by finding the angle theta between the two vectors. So if you recall, I'm going to write it again. That angle theta is going to satisfy cosine of theta equals the absolute value of the dot product of n1 with n2 divided by magnitude of n1 times magnitude of n2. Now, technically, that absolute value isn't part of that formula, but here we're going to make sure that theta is between 0 and pi over 2, and so that's why we're tossing in that absolute value. All right, so what does that mean? The two planes are going to be perpendicular if what happens? Well, they're perpendicular if that angle theta is 90 degrees. And we've talked about that happens when that dot product on top, n1 dotted with n2, is 0. And they'll be parallel. Well, they're parallel if their normal vectors are parallel, right? And those normal vectors are going to be parallel if one is a scalar multiple of the other. So if n1 is a scalar multiple of n2. All right, so I'm going to ask you to read example 4 in the book. I'll write that down in just a second. Example 4, read in the book. This example goes through finding that angle between two planes. Okay. Let me go through, you read the example to find the angle. Let me go through the how you would find their intersection, okay? So we've got two planes, x minus 2y plus z equals 0, and 2x plus 3y minus 2z equals 0. And I want to find the line of intersection. Okay, well, points are going to be on both planes if they simultaneously satisfy both equations, right? So what I want to do is simultaneously solve the two equations. Now I've already got them lined up here. And so you might notice if I were to multiply, say, the top by 2 and add the two equations together, that would at least eliminate the z variable. So let's do that. So I get 2 times the quantity x minus 2y plus z equals 0, and 2x plus 3y minus 2z equals 0. And let's add those. So I'm distributing that 2 in. So I get 2x plus 2x, which is 4x. And then minus 4y plus 3y, so minus y. And then the z's cancel, right? Plus 0 equals 0. And so moving the y to the other side, I get 4x equals y. Okay. Now let's plug into the first equation. So I get x minus 2 times 4x plus z equals 0. So this is negative 7x, plus z equals 0. So z equals 7x. And now I've written z in terms of x and y in terms of x. So let's let x be t. And then that means that y is equal to 4t and z is equal to 7t. So the line with parametric equations, x equal t, y equal to 4t, z equal to 7t, lies in the intersection of the plane, or gives the intersection. All right, I'm going to ask you just to look at the last bit of this section about sketching planes and the distance. We'll talk a little bit more about the distance between two planes in class on Monday. But you should have enough here to get started on this homework. As always, you can email me with questions, and I will see you next time.